So Unit 1, Day 4, Symmetry. Reminder that on Friday, Worksheet 1 through 4 is due. So the question was, like, how much accuracy? Well, I don't have time to grade 4 worksheets times 150, 140 students times 25 questions. Like, that would be a lot of grading. So generally what I do is I pick 2 or 3 per worksheet to grade for accuracy, and then basically count the rest as completion. So I'll check it and make sure it's not garbage, but I'll also actually grade 1 or 2 or 3, depending on the worksheet, per worksheet. So is it completion or accuracy? Mostly completion, but I do, again, I look to make sure it's not garbage written down, and I will check some of them.
Do you grade them in class on Friday, or do you just take it up on Friday and we get it back on Monday?
I'll take it up on Friday and I'll give it back on Monday.
Okay.
Yeah. So I will definitely, if I take up homework before a test, like I'm doing here, I will definitely get it back to you before the test. That way you'll have it to look at. And so I will almost never take up homework the day before a test, because then I can't get it back to you and you need it to look at. So yeah. And even 2 days before the test, just in case my goal is to get it back to you before the test. That way you'll have it to look over, for sure. Good questions. All right, let's talk about symmetry. Some of this is really easy. Like Roman numeral 1 is pretty easy. Roman numeral 2 is pretty technical. It's not difficult, but it's definitely more technical than Roman numeral 1. And I guess that's because Roman numeral 1 is like visual stuff, graphical stuff. Roman numeral 2 is letters and algebra, and be careful. And Roman numeral 3 is like one line, so just so you know what's coming today. So Roman numeral 1, the instructions will be, make the graph have a certain type of symmetry. 3 types of symmetry. And some of you, if you're visually aware and maybe good in art, you're spatially can see things, this part is really easy. But even if you're not, there's ways to do it that are more sort of mechanical, more rote. That's usually how I end up doing it. So the first graph, or the first assignment will be make the graph have y-axis symmetry. Make a graph have y-axis symmetry. Well, let's start with the graph so that we know what we're talking about here. So we'll have a point at -3, -2. And we'll have another point at 0, -3. And then we'll draw a ray. There's a geometry word you probably haven't used in a while. A ray from A through B. So that's our starting graph. To force that to have y-axis symmetry. So I wanted to make it where if I fold the paper on the y-axis, it copies onto itself. Now, a few people, maybe not a few, I don't know, some people can just sort of visually copy it across the y-axis. They can just like see what it means to fold this part over to there and this part over to there, and they can sketch it and be done. If that's you, that's fine. You can do that. If you have a hard time seeing what's going on, then the more mechanical process is to say, change the sign of the, which coordinate should I change the sign of if I want to? Yeah, I want to change the x. That will flip it left and right. So maybe that seems weird. To make it flip across the y-axis, you're going to change the x coordinate because that will accomplish the flip. So point A is -3, -2. And I want to change that to this new point A. So I change the x-coordinate to +3. So there's my new A coordinate. Again, you don't have to show the work of changing it. Some people are just going to be like, well, look, it's 3 away from the y-axis on the left, so I'll move it 3 away on the right, and there it is. And that's completely okay. Point B is at 0, -3. What happens when I change the x-coordinate of point B? And I change its sign? It's almost a trick question. Nothing happens. It's still 0. So because B is on like the fold line, the reflection line, it doesn't go anywhere. So I need to connect the line from A through B. So there's my graph that now has symmetry with the y-axis. And if you wanted to fold it to check, like you could fold it over the y-axis and even like hold it up to the light and make sure, but it's a little bit overkill. But if you need to do it, to check it, then by all means do it. All right, next let's make the same picture have x-axis symmetry. And I'm going to start with the same picture. So -3, -2 is point A. 0, -3 is point B. Draw a ray from A through B. So same starting graph. Now I want my picture to have x-axis symmetry. And again, some of you can just visualize flipping it across the x-axis. Copy across the x-axis. So you just flip it into the top. And if you can just sort of immediately visualize where the points are, then go for it. If you need to slow down and kind of go point by point, then we'll change the sign of the y coordinates. So point A was -3, -2, and we're going to change the y coordinate to a +2. That will have the effect of flipping it into the top. So -3, +2. There's my new point A. Point B is 0, -3. So my new point B will be 0, +3. Again, or you just count up 3 to the x-axis and then 3 to the other side. And again, there's a pretty nice visual check at the end. Yes, that's flipped over to the top. I feel like most people can accomplish the y-axis and x-axis flips visually without having to go through point by point. Some folks don't do all the points. They'll do like 1 or 2 points to make sure it's kind of in the right spot, and then visually do it from there. Whatever it takes. The origin, though, is a little bit trickier. Symmetry with the origin. Let's draw our picture again. Again, same starting picture. Point A at -3, -2. Point B at 0, -3. A line from A through B. Okay, symmetry with origin. This is a little bit trickier to visualize. Maybe because there's two ways to do it, but one way to do it is to rotate that picture 180 degrees. And so that would mean if you put your pin down at the origin and then you rotate your page 180 degrees, that's what the new graph should look like. But that's kind of hard to visualize what that is, so keep that in your brain. Flip your paper back and then draw what you were just looking at 2 seconds ago. Most people can't remember what they were looking at. Another way to do it is to copy across the X and Y axis. Again, that's kind of hard to visualize because I think most people can visualize what one flip would make, but to visualize flip it this way and then flip it the other way, like that's a lot to be thinking about. So the last way to do it is to change both signs. So point A is -3, -2. The new point A, change both signs, so +3, +2. Point B, 0, -3. If I change both signs, well, changing the sign of 0 doesn't do anything. Changing the sign of -3 to a +3. So now I've got A prime and B prime, the new A, the new B. The ray goes from A through B like that. And then if you want to check, it's easier to check with someone else, which is of course not allowed on the test, but while you're working, so like leave your paper the same and I'll rotate mine 180 degrees and compare my rotated picture to the picture that you have, and they should be the same. But it's tricky to like mentally take a picture of what that looks like, rotate it back, and then remember if it's the same picture or not. Alright, so that's not too bad, especially the first two. The third one, origin, takes a little more time. Be careful. Roman numeral 2. So if you don't have a picture, and we want you to determine algebraically if an equation is symmetric with, so there's 3 different types of symmetry, there's going to be 3 different tests. And I mean, this is always the case in math class, but especially on these tests, I need you to show the work. Partially because some of you are going to get to the point where you can kind of catch what's going on and you can sort of figure it out, but I need you to show me what you've done so that I know what you were looking at. So we're going to make a table here. There's a y-axis test, an x-axis test, and an origin test. And the tests are very much related to how we drew them on the in Roman numeral 1. So for the y-axis drawing thing, we changed the sign of the x. We're going to do the same thing here. We're going to replace x with negative x. Again, and what that means is negative x is going to go in for x. The x-axis test, you could probably guess, is to replace y with negative y. Negative y goes in for y. What do you think the origin test is? Both of them. And then the question you have to answer, I guess this is one nice thing about the test. So the setup is different for each one, what you do, but the question you ask after you do the setup part is the same, and that is the new equation, so you've made some changes, you've changed some x's or y's or both, is your new equation equivalent to the original equation? And if it's yes, then it has that type of symmetry. If it's no, it doesn't have that type of symmetry. So let's see how that works with a couple of examples. Find the symmetry of x equals 2y squared plus 7. And when I do these, I'm going to set it up just like I set up the notes up there. I'm going to make a little table, make my substitutions, and see if I get back to the original or not. So for y-axis, that means I'm going to put negative x in for x. So negative x goes in for x. And then my question is this equation the same as the original equation? Don't overthink it. No, those aren't the same. There's a negative x out there. That's a positive x. So y-axis is a no. X-axis means put negative y in for y. So instead of writing y, write negative y. Leave everything else the same. What happens when we square a negative? It becomes positive. Aha! Is that the same as the original? Yes. So that thing does have x-axis symmetry. Let's do the origin test. That's just switching both of them. So negative x in for x. Negative y in for y. I need to see at least that much. I need to see you make the substitution. Most of you eventually will get to the point where you can tell from here, is that going to be the same as the original? No, kind of for the same reason. Like the x is stuck at negative, the y gets fixed, but that's not enough. So that's a no. So only the x-axis, the only symmetry this equation has is with the x-axis. Like
Wouldn't it only pass the origin test if it passes both the x and the y axis test?
So you have to be careful how you phrase that. How you phrase that, the answer is no. If I phrase that a little bit differently, I can say if it passes y and x, then it will definitely pass origin. Let's look at one more example.
But it can pass origin, but not both?
Yes.
But if it passes both, it passes origin?
Yes. There's a couple of little tricks like that if you pick up on and remember, it helps, but you don't have to know those. So Blake has noticed a couple of them. There's one more that actually we won't even see, but you might figure it out as you do the homework. Let's find the symmetry of y cubed equals x minus 2x cubed. Y cubed equals x minus 2x cubed. And again, when I do these problems, I'm always going to set them up with this table. That way I won't forget one. Plus that provides some parallel structure, keeps my work organized. So y-axis means negative x in for x. So y cubed equals negative x goes in for x. Let's see. Sometimes I've got to simplify before I know what's going on here. What happens when we cube a negative x?
Stays negative.
Stays negative. But there's a negative 2 on that. So that's going to become plus 2x cubed. So what do we think? Yes or no? Yeah, that's a no. X-axis means I'll change the y to negative. Leave everything else the same. If I cube a negative, I get a negative. So that's a no. That's not the same as the original. And then with the origin, negative y cubed equals negative x minus 2 times negative x cubed. Again, the color is maybe overkill, but there's always 1 or 2 students per year that will keep using the color on their own, and that's fine. It helps them maybe see exactly what we've done. Let's see, cube a negative, we get a negative. That's negative. And we already saw this one. Cube a negative, we get a negative, but times negative 2 makes us have positive 2x cubed. Is that equivalent to the original?
Yes. Because you can cancel out the negative.
If we multiply by negative 1 or divide by negative 1, it's like all of the negatives cancel each other out, and it does get back to the original. So yes, we do have symmetry with the origin. So Blake, back to your question. If x is yes and y is yes, then origin has to be yes. If x and y are both no, origin might be yes, might be no. We don't know. And there's one other thing in there that you might pick up on. It's not worth talking about because it gets confusing. Just do all the tests and you'll be fine. If you start picking up on little things, add that to your brain, but you don't have to.
Origin is no, it can't be both.
So if origin is no,
It can't be x and y.
it would not, it couldn't be x and y. That's true. Yeah. These are like logic statements, if then, contrapositives and all that stuff. Geometry. Even, odd, neither. This is like one additional line of notes, so if you're at the bottom, don't turn the page yet because you can squeeze this on there. Even is the same thing as y-axis symmetry. It's just a different name for it. Odd is the same thing as origin symmetry, just a different name for it. And neither means not y-axis or origin. So it's just a different name for the same tests. X-axis doesn't get a name because these are for functions. And if something has x-axis symmetry, is that a function? No. So you can't have something have x-axis symmetry and be a function because it can't copy onto it. It doesn't work. So that's why x-axis doesn't get a special name. So y-axis symmetry is an even function. Origin symmetry is an odd function. And if it doesn't have one of those, it's neither. Alright, today's assignment is worksheet 4. It's like 4 pages, but it's still only 25 or so problems because a bunch of them are graphs. And honestly, it kind of goes quick because a lot of this is visual stuff. It's a quick answer. There are a few that are the technical plug in the negative stuff to see if it works. But a lot of people either finished or got real close to finishing in first period. And reminder that on Friday, worksheet 1 through 4 are due.